excited for this session because this is the one where we get to talk to you guys about all of the different ways and reasons that customers are migrating their Hadoop footprints into Google Cloud. We are going to save some time at the end for questions because we know this topic gets a lot of those and a lot of unique questions. So please, we are going to run a Dory out of the app. Go ahead and pop them into the app. And as you think of questions that we go through, put those in. And we'll try to get to as many as we can at the end. So I'm going to hand off to Blake in a little bit to tell you about how customers are actually moving their Hadoop footprints to GCP. But before you do that, I'm going to discuss a little bit of why they're coming to Google Cloud in the first place for their Hadoop workloads. So there's a lot of benefits of migrating Hadoop to Google Cloud. First of all, it's pay for use. So that's just like the rest of the cloud. You can start to map your infrastructure to real usage. Now, usually, that's a really great fit for these Hadoop, Spark, analytic workloads where you have a lot of variability. You're also going to get managed hardware and software. So just think about the task of keeping up with all of the open source security patches that are out there every week. That can be quite a daunting task and something just one of the many things GCP can help with. You can also, as you move Hadoop into the cloud, you get to keep the majority of your existing code. So usually there's only minimal changes that are needed to run your on-prem Hadoop and Spark software on Google Cloud. You also get a lot of flexibility. So there's a lot of knobs that you can turn in GCP. And so most of those things that you're going to do to customize your on-prem cluster, you'll be able to do that in Google Cloud as well. And finally, and this is the really big one, is that Google Cloud can really help you unlock a lot of your HDFS data that might be siloed in various clusters and hard to tap into. And I'll do a whole section on that in a bit. So Google Cloud, we've been trying to solve data problems for a long time. It started in 2004. We came out with one of the original MapReduce papers that got turned, a lot of those elements got put into the original Apache Hadoop. About a year later, we released a paper about Bigtable, and that had a lot of NoSQL databases, and a lot of that got put into HBase. More recently, we've even open sourced things with machine learning code and TensorFlow. Now, about 10 years back, we started to actually take a lot of that infrastructure that was built, research papers, things that were battle tested on Gmail and Maps, and we started to put those out as products that any company, regardless of if you're a startup in a garage or a large enterprise, could go use and start to use the same technology that Google was using. And so we took all of this knowledge from research and open source and running our own cloud platform, going all the way back to 2004 with that first MapReduce paper. We took that and we put it into Cloud Dataproc. And if you're not familiar with what that is Google Cloud Platform, fully managed Apache Spark and Apache Hadoop service. I'm saying Hadoop and Spark, but really this is an engine for running lots of open source software within that ecosystem. And we're going to give you things like customizable machine types. So let's say you have a batch of machine learning jobs. Those could live on a cluster that's got very compute-intensive specifications. At the same time, you could have a lot of BI applications and dashboards and interactive SQL that's running on a cluster that's very memory-heavy. The two never have to contend for resources, but both could still be reading and writing from the same data sets in cloud storage. And we also offer a lot of tools and features specifically designed to help you with those kinds of architectures, as well as ephemeral Hadoop and Spark architectures in general. We're also going to try to give you tight integration back to the rest of Google Cloud Platform. The idea with Cloud Dataproc is that we're not just giving you yet another cluster to manage. We're actually going to let you run your open source software, but in a way that will actually modernize your stack at the same time. We also give you a lot of flexibility when running Dataproc. We expose a lot of those knobs that you can turn. Now, we try to put some sane defaults on those knobs, so if you don't want to deal with them, you can get started very easily. But if you do want to start tuning the knobs, you have the ability to get in there and do that. But that also means that customers are using Cloud Dataproc in a few different ways. So a couple of the common models that we see customers using Cloud Dataproc with is, first off, what we call the job-scoped cluster model. And this has been really effective for Cloud Dataproc customers with batch processing and ETL workloads. Essentially, in this mode, you can have a single command that sends a graph of jobs to Cloud Dataproc. We will spin up a right-sized cluster, run those jobs, then take down the cluster while keeping everything logged into Stackdriver. And this is really easy on Cloud Dataproc, really effective, because we can usually spin up a fully loaded Hadoop cluster in around 90 seconds. So when you only have about a minute and a half overhead to get yourself a fully loaded Hadoop cluster, you really can start to think about jobs and clusters as a single entity. And we have and Cloud Dataproc has a lot of features like the Jobs API, workflow templates, and scheduled cluster deletion that can help with this model of job scope clusters. But we also have customers that have scenarios for long-running Dataproc clusters. And some of those situations include shared interactive or ad hoc analysis with web-based notebooks like Jupyter or Zeppelin, or BI dashboarding applications based on things like Druid. And we have a lot of features here that help as well, things like our autoscaler or our high availability mode. And if you want to learn more, I actually did a top 10 tips for long-standing Dataproc clusters a couple months back. There's a webinar associated with it. So there's lots of materials out there if you want to learn more about how to do long-standing Cloud Dataproc clusters. But regardless of the model that you choose, our goal is to change open source software to be cloud native. And so this means making features that are going to be fast, easy, and cost effective. Last year alone, Cloud Dataproc launched more than 30 features. So this is still an area that Google Cloud is really investing in. And I'm calling out cost effective here. And we actually had some external validation that we're building some cost-effective features. We worked with an analyst firm, ESG, who came back and told us that compared to an on-prem self-managed Hadoop cluster, Cloud Dataproc's about 60% less expensive. And even compared to some of our competitors like Amazon EMR in the cloud space, we still came in about 32% less expensive in terms of total cost of ownership for these Cloud Dataproc clusters. And so cost is an obvious optimization, but most customers that are coming to Blake and I, it's not cost that's the main driver. They are really coming to us because of a desire to make better data-driven decisions. And this is usually the appeal of the cloud migrations, much more so than just cost alone. And the key to making that happen is really unlocking all of the data that is trapped in your HDFS clusters today. And so I'm actually going to do a full section on converting HDFS to Google Cloud Storage, because this is really imperative to achieving cloud freedom for a cluster. This is what really severs that dependency between storage and compute. Now, luckily, this is in code, in the Hadoop code itself. It's often one of the easiest changes to make. Usually, it's just as simple as a prefix change. But the bottom line is that you can't really scale HDFS because that storage is still tied to compute. So you're taking a very pricey resource of compute and tying yourself to a relatively inexpensive resource of storage. Not only that, but you're also siloing all of your HDFS data to a single cluster instead of exposing it to all of the different possibilities that a cloud provider like GCP could offer. Now, there are some reasons to still use HDFS in the cloud, especially on Dataproc. You might have some local storage devices, so you can do things like scratch space and shuffle data, or like an LLAP cache. But the idea is that's all pretty much temporary data. You want everything that you plan to maintain to be written to cloud storage. And the reason why you can do this file system substitution, it's because Hadoop has this abstract notion of a file system. And HDFS, that's just one implementation. There's a Java abstract class, fs.filesystem, and that can call into various replacements for HDFS. All MapReduce or Spark really care about is getting blocks of data. And so this idea, this concept, it provided a lot of advantages when HDFS was first developed, and it still does now as well as we kind of move to the cloud. And I don't have time to deep dive on everything in this slide. I did release an article a couple months back if you care about comparing cloud storage directly to HDFS that does deep dive on a lot of this and does a full comparison. But the too long didn't read version of that is that you can pretty much replace most of your Hadoop jobs that are in HDFS with cloud storage. And that does not mean that you pull the data from cloud storage into HDFS. It means that your Hadoop and Spark jobs can read directly from cloud storage, just as they can HDFS over our Google Cloud Storage connector, which is an open source connector for doing just that. There's also a couple differentiators that you should be aware of with cloud storage versus other cloud providers. So in particular, our cloud storage, we're going to offer a strong global consistency for a lot of those operations that you care a lot about with Hadoop and Spark. So you don't have to be afraid to use cloud storage as a destination. If you've worked with object stores on other cloud providers, you may have had to introduce some kludgy workarounds with like a NoSQL database that sits in the way to make up for their eventual consistency. But you don't have to do that on Google Cloud. I was working with one customer, and they said they were trying to move to another cloud provider for over a year. And they couldn't get it done. There was too much conflicts in all the different writes they were doing. They tried to do a POC before giving it up. They tried to do a POC with us. And in 3 weeks, they were able to get done what they couldn't get done in a year trying to get on another cloud provider because of this strong consistency. In addition, our renames are metadata operations. So what that means is a lot of other cloud providers, if you were to do a Hadoop move, all of the data associated with that Hadoop move, that's going to actually get copied to a new part of object store. And then you're going to have to wait for that to happen and then wait for all of the old data to also get deleted before you get a return from your Hadoop move. For us, all of that happens as a metadata operation. You're not actually going to have to move the data around. Another differentiator that we have is that across Google Cloud Storage, we're going to give you different storage classes for cost optimization. But you're actually going to get a consistent API across our storage portfolio. So you don't actually have to change your Hadoop or Spark code as you move across these storage classes. You can get direct access to the archive. You don't have to go to a different service, wait hours for a restore, and then rerun your code. You can just go. Even between our regional and nearline storage classes, you can even get the same less than a millisecond latency on first byte reads. So in the context of Hadoop, just the way to think about our storage classes, regional storage, this is what you're going to use for your interactive Hive Spark analysis or batch jobs that might occur more than once a month. Next, you're going to have nearline storage. And this is for batch jobs that are really used for reporting or aggregations. The rule of thumb here is data that you expect to use about no more than once a month, you'll put into nearline. And then finally, cold line storage. That's for your post-process data. Things you really don't expect to use again, but you want to keep around for either compliance reasons or just to have it just in case. That can be moved to cold line storage. Rule of thumb on that one is data you don't expect to use to touch again more than once a year. And so once you've made the shift and you're able to move your HDFS data into cloud storage, that opens up a lot more possibilities of things you can do with it. So if you have multiple distributions of both Hortonworks and Cloudera on, in your environment today, both of those can talk over the GCS connector directly to cloud storage, while at the same time it opens you up to use a lot more Google Cloud tooling. So you can start to incorporate maybe Dataproc for some of your batch processing. Or maybe you can start to move some ad hoc stuff into BigQuery and access cloud storage via external tables. Or even start to introduce new streaming type applications with data flow on top of all the same data sets, and you can be sure that everything is strongly consistent. So if you want to make the move, you can move an entire petabyte of data from HDFS to cloud storage in about 3 steps. What you would do is you would come into the Google Cloud Console and request a transfer appliance. We would then ship you a storage device. It would look something like this box on the screen here. You would put it into an NFS share capture mode, mount those NFS shares to each of your data nodes in your Hadoop cluster, and then it's just as simple as running the standard distcp Hadoop command, and you'll copy all that data over in parallel. At that point, you just ship us the device back, and we'll go ahead and load that into cloud storage for you. Now, if you don't have a petabyte of data that you want to move right away, but you just want to start with some proof of concept or maybe a data set size that can move comfortably across a VPN connection, you can simply install the Google Cloud Storage connector on an existing on-prem Hadoop cluster, and then copy the data over with a DistCP. I think, as far as I know, we're the only cloud provider that supports not only copying of the data over DistCP, but copying of the metadata attributes from HDFS as well. So if you don't know what I'm talking about when I say metadata attributes, what this means is these are a file system feature that are going to allow user applications to associate additional metadata for a file or a directory. Oftentimes, you'll see applications do this for things like maybe what encoding was used. But when I ran across this, I was working with a large bank, and they wanted to do a full HDFS backup, keep everything encrypted as is, just get it copied over to cloud storage. And what they were doing is they had an on-prem HSM that was storing the key locations in the metadata attributes. And so when they were comparing cloud providers, they were looking and saying, well, if I go to some other folks, I would have to figure out a new encryption scheme or decrypt everything before I moved it over. But with us, it was just as simple as running that distcp-px command. The px stands for preserve attributes. And we were able to take all of both the HDFS data and the metadata attributes, and they could use it as their backup. But once that data is available in Google Cloud Storage, now that's going to let you take a really hard look at your existing Hadoop cluster and see what workloads might make sense to move to Google Cloud. A common workload target to start with is they take an on-prem Hadoop cluster that might be pretty monolithic and sharing both ad hoc analysis and batch reporting. So they have business users that are in there, and they're struggling to get their SQL queries to run because over the last few years, people have scheduled a bunch of jobs, had a bunch of stuff in batch. They're just now piling up, and they're contending for resources. So it's an easy way to get started in the cloud is they just start to offload a lot of that batch stuff to Cloud Dataproc, which frees up their on-prem resources for the business analyst. But Cloud Dataproc, it might not always be the best choice depending on your goals. For instance, a lot of ad hoc Hive SQL, that migrates really well to a BigQuery, our serverless data warehouse. Also, there might be streaming applications that fit better with data flow. But regardless of your tool or application, having that data in cloud storage, that's what's going to give you the freedom to modernize your environment and actually start to pick the right tool for the job, instead of just being limited to the tools and the compute resources that are on that single HDFS storage cluster. Now, we aren't doing this alone. We have a lot of partners in this space that can help. We are partnered with all the traditional Hadoop vendors to help you with data processing. We have partners that can help with data ingestion and movement, and service partners that can actually be your hands-on keyboard to actually get you migrated. In addition, we have some new partnerships for some niche solution providers that can bring a unified kind of experience to Hadoop and Spark, and you're going to hear more about that in our data analytics keynote tomorrow. But like I said, the big three on-prem Hadoop platforms in this space, they all support the GCS connector today. So you can move your data between HDFS and cloud storage, or you could even process cloud storage data directly from these platforms. We're also partnered with folks like Informatica, among others, who can support very complex enterprise data workflows. And they really help because they integrate deeply with GCP services, but also your on-prem scheduling systems today. And finally, again, we have migration partners that actually can get this stuff moved. We have a lot longer list than just these. But these are the partners that we know, that at least I know, have a lot of proof points for successfully migrating customers from on-prem Hadoop to GCP relatively quickly. So with this, I'm going to hand this off to Blake, who's going to he gave some firsthand experience on how he's actually migrated some really massive Hadoop footprints to the cloud.
Thanks, Chris. Hi, everyone. So first, we're going to talk about some reference cases. We tend to see a few Uber patterns that people follow in their move to Google Cloud Platform in terms of Hadoop and Spark, and we're going to tell that through a couple of customer stories. So first off, with the Uber patterns, we tend to see three primary use cases. So the first is lift and shift. These are customers that are looking to lift and move to GCP because they're having pain around scaling, elasticity, globalization, et cetera. And they sometimes want to move very quickly, and sometimes they want to move without risk. That can drive them to kind of the lift and shift pattern. Sometimes customers will decouple storage and compute, and sometimes they will not. And we'll talk a little bit about that later. The customer example we're going to go over today is Twitter, which started their Google Cloud platform journey about a year ago and has quite a few talks here at Next 19. And the kind of partner technologies we kind of run into in this case are things like on-premises Hadoop distributions, Cloudera, Hornworks, MapR, as well as customers that use Apache BigTop and customize themselves. The key GCP services that are used are GCE, Google Compute Engine for raw compute, as well as Google Cloud Storage that we kind of went over today. Next is lift and re-architect or modernize. These are customers that are, they want to kind of alleviate more than just, they want to realize more than just the decoupling of storage and compute or the elasticity of the cloud. They want to reduce operational overhead. They want auto-scaling. They want to just pay for the resources that they need, use things like auto-scaling and et cetera, by using kind of dynamic and ephemeral clusters, kind of like Chris was telling earlier with the pattern. We're going to go over a great customer example of 3PM Solutions. And the key services are used here are on top of the two that we already discussed, Dataproc for a managed Hadoop and Spark environment, as well as Composer, which is our managed Apache Airflow. Next is transform to cloud native. So, customers that are looking to kind of really transform how they're doing batch stream processing and adopt kind of like cloud native products. These are customers that are usually operating at the high end of the data scale. They're looking for advanced things around object lifecycle management. They're looking to kind of streamline their batch and streaming pipelines by using a unified analytical engine, which we'll go into a little bit earlier. And on top of just using the technologies that we kind of talked to today, they're also doing things like ML engine or BigQuery. They're doing ML or BigQuery. And I guess one last point here is that this is not necessarily a sequential journey. Some customers target lift and shift, and then not only do they migrate to lift and architect or transform cloud native, but some customers kind of make the jump immediately to cloud native. So your journey is dependent upon the time, the risk risk profile, and a lot of other factors. And Google Cloud can help you make the right choice. So the first pattern we're going to kind of go into is kind of lift and shift. So what we see here is that customers typically have a monolithic Hadoop cluster that's running on premises. We're co-locating storage and compute, and across an interconnect or a VPN, we are moving data using DiskCP or in some cases the Transfer Appliance that Chris talked about earlier into Google Cloud Storage. That Google Cloud Storage can be used in one of two ways. For clusters that are being spun up with the goal of being decoupled from their storage, the compute is created in GCE with the distribution of your choice. Edge nodes are added with the tools of your choice, things like Jupyter Lab, Zeppelin, et cetera. And they directly use the GCS connector and the GS prefix to access the data in cloud storage. For clusters that are also hosting data on the GCE VM's local disk for HDFS, customers are looking to use tools such as Impala, which has limited connectivity to Google Cloud Storage at this time, will then saturate the data in HDFS from Google Cloud Storage. So a customer that is kind of doing this very, very successfully, we have a lot of customers actually doing this successfully as a starting point and moving into the cloud, but one of the largest is Twitter. So Twitter has currently on premises in their various Hadoop clusters around 500,000 cores of Hadoop. Some of these clusters are as large as 12,500 nodes. There's under 300 petabytes of data under management, and these systems process over 1 trillion messages per day. The breakdown of the workloads is kind of seen on top. Pardon the image clashing colors, but we see that processing and production, batch processing, using scalding is about 30%. Real-time production processing is about 60% using quite a few tools, and ad hoc processing in tools like Presto and Hive is about 10%. Twitter is actually quite vocal with their journey to the cloud, and they're continuing that trend by presenting multiple talks at Google Next 2019. So what we see here is a couple of talks. They kind of primarily break down into how is Twitter migrating that much data into GCP. So if you're interested in understanding how large their interconnects are, how they use DCP, how they verify the integrity of the data, et cetera, the first talk is a great one for you. If you're looking to understand how Twitter understands and implements object lifecycle management policies in Google Cloud and basically extends their on-premises custom tooling that they do open source, the last talk on what the architecture is for data storage in GCS and how user identity management comes into play. Great sessions. So the second pattern is lift and re-architecture, or modernize. And so now we're getting into some of the things that Chris illustrated that Dataproc is very capable of doing. What we see here is that customers once again are moving data into Google Cloud Storage either via Transfer Appliance or DCP, but then it's really unlocking the ability for us to bring very defined resources to bear on that data, and that GCS provides near unlimited ingress and egress bandwidth to basically support all these analytical engines using the data at the same time. And so here on the left we see Cloud Composer, or Managed Apache Airflow, spinning up job scope clusters. This is traditionally done for batch or ETL processes. You can do things like understand how much data you have to ETL and dynamically assign a cluster with X amount of nodes, spin that up, perform the ETL or batch process, and then tear it down. You're only paying for exactly what you use. And at the end, you're kind of persisting that analytical result back to Google Cloud Storage. On the right-hand side, we see semi-long-lived clusters. So this aids in quite a few things. What you see here illustrated is kind of a red-black or blue-green kind of deployment where we have version 1.1 of our Hadoop image running, but we're also running a canary for a newer version of our platform. While it used to be very hard to upgrade and test a new cluster on premises, like a huge monolithic cluster, like being elastic in the crowd, the ability to spin up new clusters and basically load balance between them is makes that a lot easier. And then what we also see here is that we can build clusters for that are purpose built. We can have clusters that are built to run HBase, Druid, Presto, Spark streaming, et cetera. Any use case that requires long living clusters. On top of that, Dataproc has native integration into cloud logging and Google Stackdriver. And so you get metrics that the cluster can use to autoscale. You get metrics that help you understand the health of your jobs and what's going on through great operations tools. And then lastly, it becomes very easy to take things like Jupyter Lab hosted in Cloud Data Lab or Jupyter Lab hosted in Google Cloud Machine Learning environment and point it at your Dataproc clusters and use them as an analytical backend. And so we have 3PM solutions. So 3PM is basically a solution provider that basically pulls in customer reviews and customer listings from Amazon, eBay, and Walmart.com on a daily basis and helps sellers as well as these retail organizations understand understand the signal from that data and whether or not some product listings are fraudulent. And they originally had this solution on premises, and it was just unable to scale due to peaks in demand during events like a very busy fourth quarter retail, retail. So what they were trying to do is they basically moved it to the cloud. They wanted to spin up clusters for exactly what they needed. They wanted to run with hundreds of nodes to basically complete this with a very tight SLA of about 4 hours. So what they were able to do is analyze over 160 million customer reviews, ETL that, and put that into an HBase cluster and make that available for their end users. And what's really kind of amazing here is like when they built the solution, when it was operating at a much lower scale, that solution just kind of scaled with them. So the CI/CD and the solution, et cetera, basically scaled with their business. And so they didn't need any additional Hadoop administrators to kind of scale that solution as their business scaled. Lastly, we have kind of the lift and transform pattern, and this is kind of, it's aptly named like lift and cloud native. This is kind of getting the best and greatest out of Google Cloud Platform. And so what this is really kind of trying to show is that there's many ingestion methods, whether it be Apache Kafka or PubSub, or external providers such as DoubleClick, YouTube, Adobe Analytics, et cetera, moving data into Google Cloud Storage, Bigtable, et cetera, via many analytical engines. We can then bring any type of analytics on top of that, BigQuery, Dataflow, Dataproc, and start doing machine learning analysis on that data to support those use cases, and then just integrating with any BI or visualization tool, almost any that's in the market today, as well as Google Cloud Data Studio. This is kind of the lift and cloud native. A couple of points here, since they're kind of new. Customers that tend to lift in cloud native tend to do things like adopt Google Cloud Dataflow due to its kind of unified batch and stream engine, right? So with very little modification, you can run pipelines both in batch and streaming. While in the Hadoop world, those were traditionally done in like different analytical engines. Customers start to adopt BigQuery. We see patterns where customers will continue to do ETL in Hive or Pig in Hadoop, but then look to do interactive query in BigQuery. And then lastly, we start to see customers that go cloud native really go all in machine learning, right? So, as customers become, adept at processing data, managing its lifecycle, increasing its discoverability through other tools to its end users, we really see that in a lot of cases, queries per user in a company double 6 to 9 months after like a large scale adoption of like GCP. And so we start to see machine learning kind of enter the picture. And the company I want to highlight here is Pandora. So we've been working with Pandora for over the last 6 months. Pandora had quite a large on-premises Hadoop footprint of over 2,700 nodes, 7 petabytes of data. And internal analysts basically participated in the creation of like over 120,000 Hive tables, and that really drove like all different corners of their business. And so if you're looking to understand how Pandora is making this migration and some of the decisions that they made along the way, there's a talk tomorrow afternoon in the Palace Hotel as well that talks about how they move their on-premise analytics and interactive query to Dataproc and BigQuery. And then there's also a talk on Thursday morning on composing Pandora's move to GCP, which really kind of illustrates the journey from moving from on-premises Apache Airflow to Google Cloud Composer for a more managed experience. And so we've reached the point where we understand the tools that are available within GCP. We understand some of the common patterns that people take. And so how do you start your own migration? How do you start your own journey? So first off, it wasn't quite mentioned, but I'm part of Google's professional services organization. Google goes above and beyond in our customer set with customer success, right? So we have a very unconventional professional services organization that's not a profit center, that looks to meet their customer where they are, develops methods and processes on the fly with our customers to basically target and achieve whatever lift and shift pattern they've chosen, right? And we do that while hoping you get the most out of your Google Cloud products. And we often work with partners that, kind of Chris talked to earlier, partners that have specific expertise in Hadoop migrations to actually execute this work. So Google Cloud Professional Services has a data analytics practice within it that has migrated dozens of customers from on-premises and other public cloud providers to GCP through every single one of the patterns that I discussed earlier today. And we commonly create artifacts that we democratize via solutions on our website, blog posts, on the Google Cloud Data blog, as well as various articles on Medium. So we kind of have, over the dozens of migrations that we've actually performed, we've kind of come up with an opinionated methodology for moving customers, whether it's lift and shift, lift and re-architect, or lift and cloud native. It's kind of broken down into two major themes. The first is the plan, and that is comprised of 4 discrete steps, and the next is the deploy, which is 6. So what typically happens is, over the course of a few weeks, we lead discovery workshops where we not only understand our customer's environment, but we also educate them on the ins and outs of the GCP data stack at a very, very low level. We work with them to determine an end state that's not only a solution architecture, but also organizational changes that are required as well, and other ancillary things. Next, we work with customers to prioritize their workloads and actually deep dive into their data sets, and then actually design the migration path and plan. So that kind of wraps up the planning phase. Moving into deployment, we typically see customers immediately start to move data to GCS. When this is typically done over an interconnect or VPN connection, there's usually a long tail effort to this type of activity, and so we kind of get that kicked off pretty quick. Next is we do deployment of the big data stack, so we understand what components are required within the Hadoop ecosystem, and we work to build an environment that is optimized for those components and working end to end. Next comes moving the workloads, right? So we actually work to move every single workload, test and validate it, and at the same time integrate with other GCP services like Stackdriver, logging, Composer for orchestration, BigQuery, et cetera, right? And at the end, Google has cloud CRE and SRE processes that kind of help run the system and make sure that there's production operation readiness. So I just want to cap off this planning or migration section with a sample Hadoop migration timeline. This is customized, for every customer, for every use case, and this is kind of typically the high-level activities that we kind of see with the objectives that we try to reach. So first off, we have analysis kickoff, and we understand the architecture of the entire platform, and try to implement foundational things. So we find that to implement a big data and analytics solution, we must be operating on kind of a firm bedrock foundation, and those are things like infrastructure setup. So it's very important for us to ensure that there's the correct network design, that there is logging, that there et cetera is in place. Flipping the Hadoop migration on the previous side in another direction, we see here, we talk about the data migration, GCS configuration, understanding things like object lifecycle management, identity and access management, how not only are you going to have that first initial sync of data into GCP, but how you're going to enable the continuous delivery of data that you may be generating on premises. So all these things are kind of taken into account, and processes are created, automation is created to handle that. We find that it's all about getting that first cluster up and going, kind of defining that data platform, because once you define it once, you can spin it up multiple times. And we tend to see two kind of parallel threads where there's kind of the migration of existing workloads, after this first cluster has been created, and then at the same time, other business groups within a customer will start using this new data platform to kind of bring new use cases online. And then lastly, there's kind of the go-live preparedness, right? So bringing that production operational readiness through SLAs, SLOs, et cetera, and then before going live. And then we kind of rinse and repeat. So this is an iterative process. So with that, I want to point you to a few resources that you can basically seek out to understand, how do I make this real for me, right? So the first article is Migrating On-Premises Hadoop Infrastructure to Google Cloud Platform. This really goes into the technical details of moving data into GCS, as well as understanding what pattern is right for you. Lift and shift, lift to re-architect, lift and cloud native, and what it's like to create jobs and workflows, et cetera, right? And last, I would like to encourage you to follow with your favorite RSS reader our Data Analytics Cloud blog. You know, Chris mentioned some of the articles that he's created. There's a lot of great Googlers who do the same, and you'll hear interesting product announcements as well. And so that's cloud.google.com/blog/products/data-analytics.